Once we know our tissues, we can put them together and talk about organs. Here we discuss simple organs called membranes, and we'll also talk a bit about tissue damage and repair. We've actually already discussed simple organs called glands, which consist of a bit of epithelial tissue, which secretes some substance, connected with connective tissue. Membranes are also very simple organs. While most organs consist of all 4 tissue types, glands and membranes only consist of 2, epithelial tissue and connective tissue. Generally speaking, a membrane is a very thin sheet of tissue that's somewhat like a blanket. It covers structures that are open to the external environment, lines cavities all over the body. Membranes, in general, consist of some type of epithelium and some type of connective tissue. Often, there's secretion involved, though not always. Here we discuss several membrane types: mucous membranes, serous membranes, and synovial membranes. The skin can also be termed a cutaneous membrane, but as we'll see in Chapter 5, the skin is quite complex with many associated structures, so we'll discuss that separately. The mucous membrane consists of epithelial tissue and a thick layer of loosely arranged connective tissue that attaches it to underlying structures. The type of epithelium will vary depending on the location. Mucous membranes are found lining cavities that are open to the external environment, including digestive tract, respiratory tract, and the urogenital tract. So, for example, we might find it in the oral cavity, where it's used for protection. And because stratified squamous epithelium is so good at protecting, that's the type of epithelium we'll see there. We'll also see it in other parts of the digestive system, like the small intestine, where it will play a part in absorption of nutrients and secretion of various substances like mucus. So here we'll see simple columnar epithelium, which is great at absorption and also at creating secretions. We can see examples here of mucous membrane with stratified squamous epithelium, a pretty thick layer of squamous cells at the free surface anyway, and then our loose connective tissue down here. And then these images are the small intestine, where we see structures called villi, which are finger-like projections that increase surface area. And all the villi are lined. This is a lower magnification, so we don't see the tissue quite as up close. But this lining here is simple columnar epithelium with goblet cells. You don't see them very up close, but you can see these clear staining goblet cells that produce a protective mucus for the tissue. We've already talked about serous membranes, so you might remember this from Chapter 1, consisting of simple squamous epithelium and a thin layer of loose connective tissue. Serous membranes secrete serous fluid, a lubricating substance. Now, simple squamous epithelium is the thinnest epithelial tissue that we have. So you can see from these images that this is paper thin, right? Just a very thin layer of tissue here. While mucous membranes were lining cavities that were open to the outside, serous membranes line cavities that are totally enclosed and don't open to the external environment. And you might remember where we find them. The pericardial cavity, which surrounds the heart, right? Cardia for heart. The pleural cavities, where the lungs are located, and the peritoneal serous membrane, which is found in the abdominal cavity. So here, this serous membrane will line the body wall, line the organs, and the serous fluid produced by it will allow those two layers of membrane to slip and slide past each other, protecting our internal organs from friction and abrasion. Remember, we spoke about how there's a lot of movement that occurs when our heart contracts, when our lungs allow air to move in and out, and when the organs of our digestive system allow substances to move through them. Without these serous membranes, all that movement would result in organs rubbing against each other and against the body wall, which would cause tissue damage to occur, especially if we're talking about the entire lifespan of an organism. So these serous membranes then are instrumental in preventing that from occurring. The synovial membrane is the only membrane that is only connective tissue. So it's even simpler than our mucous or serous membranes. And it's only found lining the cavity that surrounds freely movable joints. So these would be joints like the knee joint, hip joint, elbow, or the humerus articulating with the shoulder, the arm and shoulder area. The synovial membrane contains the joint and it secretes a lubricating synovial fluid. So there are modified cells here that accomplish this secretion. The major components of these freely movable joints are cartilage. And you can see that freely movable joints can be quite complex. So we have the two articulating or joining bones here. And this isn't any specific joint, just an illustration of a general joint. There's a structure called articular cartilage here that covers the ends of the bones where they meet up with the other bone. This is composed of hyaline cartilage. And thinking back to our supportive connective tissues and our cartilages, hyaline cartilage was the most abundant type of cartilage. It was great at providing support that wasn't completely rigid and had some give to it. It was also great at reducing friction. Hyaline cartilage was very smooth, like glass. So here, it not only provides some cushioning, it also is going to allow these bones to move with a minimal amount of friction occurring here. And we certainly don't get into it here, but there may be other accessory structures that stabilize the joint and allow some more support for the joint, like bursa. We might see tendons, ligaments running through here, or additional cartilaginous structures. These synovial membranes are particularly important because cartilage is avascular, no vessels, so no nutrients or oxygen being provided to the tissue. This means that the tissue is very poor in its healing properties. It does not recover from injury well. The synovial membrane, by preventing friction, is also going to prevent tissue damage from occurring here and limit damage. This image from your book shows the three membranes that we speak about. We have our mucous membranes lining these cavities that open to the outside. So they'd be found in every area where we're open to the outside: respiratory, digestive, urogenital tract. And then we have our serous membranes lining the completely enclosed cavities, pleural, perineal, and, not pictured, but pericardial cavities. And then when we look at the joints, we will see this synovial cavity around the freely movable joints created by this synovial membrane. It's a tough, rough world out there. So our bodies, our tissues are continually being damaged. The first thing that occurs when tissue is damaged, and unfortunately sometimes when tissue isn't damaged, is inflammation. So whether it's some type of trauma like a paper cut or a broken bone or infection that occurs after tissue damage, it's going to instigate this process of inflammation. This comes about as damaged tissues and certain white blood cells release a host of chemicals called chemical mediators. These chemicals are going to increase dilation of blood vessels, which increases blood flow. This has the effect of increasing temperature in that area. It also brings more nutrients and oxygen for fueling, repair. It allows more white blood cells to be able to come to the scene of damage. Chemical mediators also specifically signal white blood cells. Phage cells, or eater cells, like neutrophils and macrophages, are able to destroy foreign materials and damaged cells and tissue by ingesting them. So like this little cartoon cell you see here, they'll take up microbes, little bits of cells, clean up the area so repair can commence. The symptoms of inflammation are very predictable and familiar, so we've all probably experienced this. They are related mostly to that increase in blood flow, which leads to redness. As blood is red, more blood is going to cause that to occur. Blood is a bit warmer than the rest of the body, so more blood flow is going to increase that temperature, which stimulates metabolic rate of our cells, which is going to cause cleanup and healing to occur more quickly. All that blood and fluid leaking from damaged tissue will cause swelling to occur in that area. And we'll also feel pain. Damaged tissue by itself is going to be painful, as there are nerve endings in our tissue that are stimulated by it. And then that swelling that occurs as a consequence of inflammation can also contribute to that pain. This leads to a loss of function, meaning that the area is not going to function as normal, and that pain and disturbance to function are going to cause us to protect that area. So these symptoms might not be pleasant, but they certainly have an important purpose. This diagram from your text shows some damage and potential infection occurring with a splinter, which we might not consider very serious damage, but it's going to set off this process of inflammation like any damage will. So here we have that splinter damaging some of the epithelial tissue of the epidermis and the connective tissue down in the dermis. This damaged tissue releases chemical mediators, which causes blood flow to increase to the scene. We also see that the blood vessels themselves are damaged, which causes blood to leak into the surrounding tissues and may also be lost to the surrounding environment. Blood vessels dilate as a result of these chemical mediators. This means that they widen, allowing increased blood flow to occur. We'll also see the fluid or plasma leak into surrounding tissues, allowing swelling to commence. That increased blood flow and certain chemical mediators are going to signal white blood cells to the scene of the crime, where they will aggregate or crowd together and eat up any debris, eat up any bacteria. You can see here, the bacteria that were introduced by the splinter are going to proliferate or increase. They're going to basically take off inside of the environment of our body. These white blood cells are going to work to control those. These neutrophils are small phagocytic or eater cells, which are going to gobble up these small bacteria. When inflammation has cleared up that area, tissue repair can take place. And repair means a substitution of dead, damaged, non-functioning cells with viable or living functional cells. So out with the old, in with the new. This can occur in one of two ways. Regeneration is when the same type of cells and tissue replace what was lost. This is going to result in 100% restoration of the tissue back to normal functioning. So we won't have any remnant of the damage. Functioning is restored and there will be no scar, as the same exact tissue has replaced what we lost. Replacement or fibrosis is when we have a different type of tissue replacing what we lost. This is usually connective tissue fibers. Because the replacement tissue doesn't function like the tissue that we lost, there's going to be some loss of functioning. The extent is going to vary depending on the type of tissue and the amount of damage. We'll also see a physical remnant of the damage as a scar develops. The new tissue doesn't look like the tissue surrounding it. Regeneration is characteristic of epithelial tissue. So the epidermis of the skin, our mucous membranes, these are going to recover quite well from damage. Whereas we'll see replacement in our muscle and in nervous tissue. And these tissues are never capable, usually not capable of restoring themselves fully. And here we can see repair taking place. So this is after that splinter has been removed and inflammation subsides. We'll see the formation of a blood clot as a temporary barrier to blood loss and to harmful elements from the external environment coming into the body. Then we see the replacement of the blood clot with a scab. And again, this is a protective structure that also knits the healthy tissue together, kind of like stitches, our body's own stitches, which reduces the chance that things like bacteria get into the wound, also aids in healing. And we start to see new tissue develop here. And the scab protects that area as that occurs. So when your mom warned you not to pick your scabs, she was right. We should leave them alone so we can heal. We can see the epithelial tissue here, healing by way of regeneration. New epithelial cells proliferate and grow in order to replace what was lost. Down here in the dermis, we'll see replacement taking place. So we'll see connective tissue fibers replacing the cells, the structures that were lost down here. So it won't function quite the same, potentially, as it did before. In this way, many of our tissues are capable of some kind of repair.